We're going to do some notes on particle motion. It's a relatively important concept in calculus, so we can kind of just tackle some of the basics of it with everything we do know, just about using our basic algebra skills and learning some new concepts along the way. So first off, we're going to talk about the notation. We have S of t here as going to represent the position. That's pretty typical of a particle at time t, that we're going to use S of t. Sometimes we use x of t. V of t is going to represent the velocity of a particle, and then A of t is going to represent the acceleration. So you'll be given different functions, and usually you just need to figure out what to do and what to plug in. That's usually the issues we're going to run with here. Example 1, by the way, all these examples are going to be the same prompts, just ask different questions. So I'm just going to highlight what's important here just ahead of time. So example 1, we have a particle that moves along a horizontal line so that its position at any time where t is greater than 0, so we're using positive numbers here, is right here, the first highlight, where S of t is measured in meters and t in seconds. The velocity gives us that as well, and then the acceleration, the other highlighted part. We need to find the position, velocity, and acceleration at t equals 1. That's what that means right here. This 1 second is t equals 1. Okay, so at 1 second, we're going to plug in a 1 into S. So we're going to do 1 cubed minus 9 times 1 squared plus 15 times 1 plus 12. So all we're doing here is we are just plugging in a 1. So if you want to use a calculator, be my guest, the answer you should get here is 19. So let's go ahead and do the measurement. Is going to be in meters. So the position, again, is measured in meters. The velocity at 1 is when we plug in a 1. So if we go ahead and plug in a 1 and figure this out, we're actually going to get a 0. So this is going to be 0. This is going to be meters per second. And then when we do acceleration at 1, this is actually going to give you negative 12 meters per second squared. Okay, so that's all of that at 1. Okay, so this is the little part that you start getting asked a little bit more complicated here, is when is a particle at rest? So that's when you set the velocity equal to 0. That's when you figure out when the particle is at rest. So it's velocity equals 0, and then you solve for t. When is a particle moving to the right? That's when the velocity is positive. And when is a particle moving to the left? That's when the velocity is negative. So example 2, the same prompt here. So we're going to have the same S, V, and A values. So it's asking now, when is the particle at rest? When is it moving right? When is it moving left? Okay, so what we're going to do here is take the velocity and set it equal to 0. So we're going to take the 3t squared minus 18t plus 15 and set it equal to 0 and solve for it. So the easiest thing to do here is to factor. First off, I do notice that all of these are multiples of 3, so I can just divide everything by 3, make my life a little bit easier for factoring. And then double bubble this. I think we're going to get minus 1 minus 5, it looks like, to get me my negative 6 in the middle. Multiply to get 5, so it's going to give me t equals 1. And t equals 5, and this is when the particle is at rest. So it is at rest at t equals 1 and t equals 5 seconds. Okay, so when is it moving right and when is it moving left? We're going to kind of do those two together. What you need to do for this is you need to make a number line. All right, so we start at 0 again because we are always positive and it's going to go on to infinity. Okay, so it's at rest at 1 and it's at rest at 5. So we need to figure out when this thing is positive. It's not, so it's going to be positive in these intervals like that, or it's going to be negative in these intervals. But the whole idea here is we're going to use this chart, this little number line right here, and make a chart. So how do we figure out if it is positive or if it is negative in each of these? Well, all you're going to do is take a number that's in between. So for this case, like a 1/2. And we're going to plug it back into our velocity. It's probably easier to plug it back into this factored form right here to figure out if it's positive or negative. So if you have 1/2 minus 1, that gives you a negative value. If you do 1/2 minus 5, that gives you another negative value. So you have a negative times a negative, which is going to give us a positive. And this is something we did back in the first semester. Pick a value that is between 1 and 5. Just go ahead and just pick a 3. If you plug a 3 back in, you're going to get 3 minus 1 is positive. 3 minus 5 is negative. Positive times negative is negative. And then plug in a number that's bigger than 5. So like let's pick a 6. 6 minus 1 positive. 6 minus 5 positive. So this is going to end up being positive. Okay, so I'm just using skills that we have learned in the first semester. Nothing new here with that chart. What is new is how do we use this chart? Well, when are we going to the right? We're going to the right between 0 and 1, and 5 to infinity. So we are moving to the right from 0 to 1. So putting this in interval notation, and 5 to infinity. Because velocity is positive. And we're moving to the left between 1 and 5. Because velocity is negative. Example 3, same prompt. Except to ask this, what's the position of the particle when it's at rest? And what's the acceleration of the particle when it is at rest? So we have two different moments. We have at t equals 1. Well, we already did that up here, right? So at t equals 1, I have my position and I have my acceleration. So v of 1 is, we said 19 meters. And a of 1 is going to be negative 12 meters per second squared. Now I'm sure you're wondering, well, if the velocity is 0, isn't the acceleration 0? Don't forget, this is just at an instant. It's not at a long time frame. It's just for a small instant that the velocity, and I just noticed I wrote v. This should not be a v. This should be an s. That the velocity is 0, but you're still have an acceleration, because it's not, if it was 0 for a lapsed amount of time, so like if you had a velocity of 0 for 1 second, then yes, you have an acceleration that's going to be 0. But this is just for a split second, the velocity is 0. It's really, just imagine running in one direction and then quickly turning around into another direction. Okay, you're still accelerating, just even though when you, that exact point where you turn around, your velocity is actually going to be 0. And then let's do the other value that we were at rest at 5. So at t equals 5, so we're going to find s of 5. So you're going to come back up here and plug in a 5 into, just like we did here with the 1. So when you plug in a 5, you're going to get negative 13 And then when you plug in a 5 into the acceleration, hopefully I don't mess this mental math up, you're going to get 12. Okay. All right, displacement. What is it? And how do you find it? It's just going to be the final minus the initial. So displacement is just from where you finished versus where you started. That's all it is. Okay? So same prompt here. Let's find the displacement from when it starts to 6 seconds. So we're going from t equals 0 to t equals 6. So all we're going to do here is we're going to do s of 6 minus s of 0. Okay? So if you want to find out s of 6, just plug in a 6 into that equation, and you're going to get -6. Minus, plug in a 0 into that equation, and you're going to get a 12. So -6 minus 12. And that's going to be a -18 meters. So after 6 seconds, we are 18 meters away from where we started. That's what displacement is. Now, distance traveled. This is where it gets a little bit more complicated, even though it seems like something that'd be pretty straightforward here, just because we're more familiar with how much distance did you travel. Distance traveled is not displacement, so let's take a quick look at this path, this particle, at this number chart right here. So at 0, okay, we're going in a positive direction. We're going to the right. But then from 1 to 5, we're going left. And then from 5 on, well, 5 to 6 in this case, we're going to the right. So it makes sense that we're going right for a second, but they're going left for 5 seconds, and then we're going right for just 1 second. That makes sense why my displacement is negative, because I'm going left a lot more than going right. But for the distance, I actually need to find the displacement of each interval. So it kind of sounds a little complicated how I'm going to write this down, but I'll explain it. So it's going to be the sum of intervals of displacement. And we have to use the absolute values, because distance is measured to be positive. Okay, so pretty much I want to find out how much did I travel from 0 to 1, how much did I travel from 1 to 5, even though it was left, I want the positive value of that, how much did I travel from 5 to 6. So distance is going to equal, well, again, I have that number line. I'm going to just quickly draw it right over here as well. So I start from 0, at 1 I'm at rest, at 5 I'm at rest, I'm going to 6. I need to find each of those intervals. So I'm going to go from 0 to 1. So I need to find the displacement from 0 to 1. It doesn't matter what order, again, because we're doing absolute value. From 1 to 5. And then from 5 to 6. I don't know, I put a plus sign right here. It should be a minus. I believe I have all these values already, because I did some of them already. So it looks like I'm going to get 0 is supposed to be 12 minus 1, which is, I did that up here, right? Yes. And 1 is 19. Plus 19 minus, and I did 5 already. That's -13. Plus -13 minus 6, which is -6. So I'm going to get, looks like that's going to be a 7. Plus this is going to be 32. Plus this looks like this is going to be just another 7, I think it is. Add those together, and I'm going to get 46 meters is how much we traveled. Okay, so our displacement is negative 18. So from when I started to I finished, I'm 18 meters away, but my total distance that I did travel was 46 meters. Coming to the end here, when is a particle speeding up? People always misinterpret this speeding up as when velocity is positive. That's not the case. Something is speeding up when the velocity and acceleration, when they're both positive or negative. So something's speeding up. Now, could it be speeding up in a negative direction? It totally could. But something speeding up if the velocity and acceleration are the same, and slowing down is going to be when velocity and acceleration have opposite signs. So if you're positive velocity but you have a negative acceleration, you're actually slowing down, and vice versa if you have a negative velocity and a positive acceleration. Now, positive acceleration means you're moving into one direction, and velocity is moving in the opposite direction if it's negative. Just kind of be aware of that. So same prompt here. When are we speeding up? When are we slowing down? So real quick, I have that number line from velocity from earlier. Going to copy it down here. We need to do the same thing for acceleration. So we need to set a equal to 0. So when we do that, we get 16 minus 18. This way I can figure out when my acceleration changes from negative to positive or positive to negative. So at 3, it changes. So plug in a 2, for instance. You just want to plug in a 2 right here to see if my acceleration is positive or negative. Plug in a 2, again, I would plug it back into here. You're going to get a negative value. Plug in a number that's bigger than 3, like a 4, you're going to get a positive value. So these are my sign charts for acceleration and then velocity. All we're going to do now is just to answer this, we're just about done here, is to compare our signs. So when are they the same? So we're speeding up. So just look at our charts here. It looks like we're the same right there. Don't we have the same sign? They're both negative, so we're actually speeding up from 1 to 3. And then looks like we have the same sign here, which is going to be from 5 to infinity, because velocity and acceleration have the same sign. Okay. Slowing down is when they have the opposite sign. So let's go ahead and look for that. So velocity is positive, acceleration is negative. There. And there. So it looks like we're slowing down from 0 to 2 and from 3 to 5. And again, this is because velocity and acceleration have opposite signs. Okay, so especially for calculus, this is pretty much what we do for particle motion. The only difference is for questions in calculus are going to be, usually we're just given a position function, and it's up to you to figure out what the velocity is and what the acceleration is. That's really about it. So other than that, that's really the only difference between calculus and what we just did today. So this is it. Worksheet pretty much mirrors this, so you get a good chance to practice, and there is a table on the worksheet as well. So if you have any questions, feel free to reach out to your teacher.